Hello again, back on the Magic TV. Today we are going to see how can we collect these simple exercises. It is an exercises of 3 questions. So let's see how we can collect. First we have to find the value of key for which the equation has 2 distinct roots, and for which the value of key the equation will have no real root. It simply means that at this point it will have a complex root. Okay, right. So let's start. Solution. Now the equation is x squared plus key plus 1 times x plus 1 equals to 0. I think simply this is quadratic equation. Okay, yeah. So to solve it, first let's calculate delta. Delta will be given by b squared negative 4ac, where a equals to 1, b equals to key plus 1, and c equals to 1. So replace this value in this equation of delta. I hope you will get key plus 1 squared negative 4 times 1 times 1 as c and a equals to 1 respectively. So here we have key squared plus 2 key plus 1 minus 4, and this will give key squared plus 2 key negative 3. Right, that is the value of delta. So for this equation to have, or generally for quadratic equation to have a 2 distinct root, delta must be equal or greater than 0, like this. For quadratic equation to have a 2 distinct real root, delta must be equal or greater than 0, like this one. So this would give us, or this will mean that key squared plus 2 key negative 3 is equal or greater than 0. Yes, I think that is also key. Yeah. So this would give us, so let's calculate this value key plus 2 key negative 3 equals to 0. I think delta would be equal to 4 negative 4 times negative 3, so it is 12, and it is equal to 16. So square root of delta will be equal to negative or plus 4, right? So I think key 1 would be equal to negative 2 plus 4 over 2, and we get 1. And the key 2 would be equal to negative 4 over 2, and we get negative 6 over 2. Then the key 2 would be equal to negative 3, right? So, and I think at this point we'll have key squared plus 2 key negative 3, which is equal to key negative 1 times key plus 3. So I place this value in this equation here, so that you will get key negative 1 times key plus 3 greater or equal to 0, right? And this would be equivalent to key negative 1 equal or greater than 0, or key plus 3 equal or greater than 0. Okay, now this will become key minus 1 greater or equal to 0, or key plus 3 greater or equal to 0. Now, at this point, we can say that to have two distinct root, the value of key must vary from 1 to positive infinite, right? That is 1 to infinite. Okay. And also from negative 3 to negative infinite. Okay, that is from negative 3 to negative infinite. So mathematically, this can be written as key 1 or key greater or equal to negative 3, and this can be written as 1, yes, 1 which is included, or key, no, here it is it is negative infinite, right, and negative 3, which is also included. So this simply means that from 1 to positive infinite we will have a 2 distinct root, or from negative infinite, no, from negative 3 to negative infinite we will also have 2 distinct roots. And this is simply means that the value between negative 1, the value between negative 1 to 1, I mean negative 2, negative 1, 0, yes, this value will make the equation to be or to have no real root. So it simply means that we will have at this value negative 2, negative 1 and 0 we will have a complex root but not real root. Let's also talk about this one. It means that to have a distinct, to have a no real root, the delta must be negative. So it simply means that key minus 1 would be greater than, would be less than 0, or key plus 3 would be also less than 0. This simply means that it means that it is a key less than 1 or key less than negative 3. Okay. This means that here we have 1 which is not included, positive infinite which is also included, and also here we have negative infinite which is not included, and negative 3 which is also not included. So this means that from 1 to positive infinite, or from negative 3 to negative infinite, and also from negative 3 to 1, the value of key will provide no real root. This is simply written as 1 which is not included, also negative 3 which is not included. So that's what we need to prove here. I think this is also equal to the set of negative 2, negative 1, 0. That is the value, that is the value required for key to have no real root. Right. Okay, I think this video is simply understandable, and so I can say that thank you for watching this video, and I wish to tell you that the more you visit Knowledge TV, the more knowledge you will gain. So thank you.